Hi, this is Laura Cecere, and I'm interviewing the technologists coming to the Supply Chain Insights Global Summit. This is Matt Yearling. He is the CEO of PINC, and he's got some really exciting technology that he's working on as we talk about Supply Chain 2030. Matt, tell the group a little bit about yourself and a little bit about PINC and what you do.
Yes, so as you said, I'm the CEO of PINC. I've been with PINC since 2013. My background has been really focused on enterprise software and supply chain software specifically. This is my second time in the supply chain, and really, what attracted me to PINC in the first place was really their core underlying technology platform. And really what that is in a nutshell is you take a sensor package, and that sensor package could be computer vision, RFID, Bluetooth, or pretty much any sensors. You put that on a mobile vehicle. That mobile vehicle could be material handling equipment or a purpose-built robot. And as that mobile vehicle is moving, that sensor package is looking at stationary inventory. And when we're looking at inventory, basically what happens is we can do several things. We can detect that something's there. We can identify what it is, and we can actually localize where that is in space. And so, what you're seeing going on behind me right now is an engineer in our warehouse, and this is just one of the uses of our platform, moving in 3 dimensions on a purpose-built robot, looking at inventory in a different way.
So, how wonderful to have real-time perpetual inventory without any counts, right? And how accurate is it?
Well, yeah, so it's interesting, right? So I was in a very large warehouse last week, and it doesn't amaze me. Every time I walk into a warehouse, I ask what the inventory accuracy rate is, and I'm told it's 99.9. It's like, okay. Then we walk around the facility and say, okay, so here's the problems that we see, and then you start seeing that even the facility that's allegedly 99.9 falls down in a number of different areas associated with the operation. Well, so the 99.9 is pretty much a human-derived number, and what we do know is that many times that's linked to compensation, right? So I'm not saying that it's a fudged or inflated number, but it's not, doesn't necessarily translate into truth. And so what we're all about is taking a human-based activity, a process, and automating that with a robot for a few different reasons. One is obviously doing that hundreds of times faster than a human can do it, but more importantly, it's all about the accuracy of that information. So taking a process that is maybe 80, 90% successful and making that close to 100% accurate in terms of identifying inventory, by a robot.
Well, Matt, how good is it on things that aren't in boxes, like maybe rolls of fabric or kegs or pallets? How accurate is it on things that, we normally really struggle to count?
Yeah, no, it's a good question. All I can say to kind of answer that question is that there are many different sensors. So kegs could have a different sensor, fabric could have a different sensor. We're dealing with a high-value apparel manufacturer that has RFID tag inventory. So there are many different ways of identifying or having something that is a proxy for that piece of inventory. Or just like we observe when we walk down an aisle, we can observe many different things associated with that environment. We can observe height, depth, counts, size, and the technology associated with computer vision and AI is getting to be able to do a lot of these things in this environment. So today, the technology is pretty much a label-driven exercise looking at inventory that's forward-facing, and obviously, as I mentioned, RFID. But it's getting to the point where, if I'm in an environment where I'm got double or quadruple deep inventory, I could be able to perceive that and do meaningful things with that information that I'm collecting real time.
Well, Matt, as we think about Supply Chain 2030, there will be a lot of people at the conference that I sure will have a lot to talk to you about. How do they prepare for 2030 working with this kind of equipment? What advice do you have?
Well, so our target customer base is obviously the 100,000 plants and warehouses in North America. That's really what our target is. And when you go around all of these facilities, they pretty much look what it looks like behind me. Obviously, not floor-mounted inventory and beverage and fast-moving product, but for the most part, it's a rack-mount environment with inventory on it. And pretty much the processes associated with looking at this inventory is the same no matter where you are, whether or not it's pen and paper, whether or not it's hand scanners, or whether or not they don't do it at all. I mean, I'm talking to a customer right now where anything from a third level upwards, they're not even looking at it. They're not even checking it. They're hopefully assuming that the information is correct, and it's only 60% correct. So that is what we see in the environment today. And I would say, if all the environments look like a traditional environment like this, if you have a purpose-built robot that goes into a familiar environment and automates the process, then it's instantly attractive. And the payback associated with that is very quick. It's measured in months. And really, it's not just the operational efficiencies, it's what you can do with that information, gathering that a lot more effectively than a human-based. And it's also richer too, right? So if I'm a human, I may lose context. I may lose a historical capturing of that information. With technology like this, not only can I see it at my desk, I can capture historical information about what was in that specific bin location, that slot location where that pallet was, last Wednesday, and and how can I look at density of my inventory and the like. There are many different things that you can do with this data, which is far more richer than what a human can capture as part of their daily activity.
Sometimes I talk to people about what you're doing, which I think is very cool, Matt, and they're like, wow, I'm just not smart enough to go do that, or I can't imagine that the operators in my warehouse could go do that. But I don't think it's all that difficult. I mean, I watch you implement where, they're not like a different kind of warehousing organization. What's your response around organizational dynamics and skill level and the ability for workers to work hand in hand with drones and automated robots?
It is the whole point. And, the expectation from a customer perspective, and I got to tell you, it's not there yet, but the expectation is I show up with a robot, push a button, and it's away. Obviously, it's not as simple as that today, but that is where we're going. And so, if you observe the gentleman behind me, the engineer behind me playing with a robot, he hasn't got his fingers on joysticks controlling this robot. It's a robot. It's fully autonomous. And when I hear war stories about people that's tried this type of drone technology, pretty much they get a consumer drone, they fly it up, they crash it, and all of a sudden it ends in tears, and it destroys confidence, and really that was it's not going to work for us. They come to a conclusion, a premature conclusion that it's not going to work. Well, so this is all about making it simple. So pretty much the way this is set up, it's you give our application, which you can run on in any browser. It's a web-based application. It's run in any browser. You tell it what bins you want to scan, and it pretty much determines how to do that. You push a button in the browser to start, and it goes up and does that. And so that's the complexity of what we're dealing with this type of technology. It has to be so easy to use that anybody can use it, because that's what we find. It has to be very easy because anybody can be trained to use this type of technology.
So Matt, our conference is a little different in that we don't have booths and tchotchkes, and this is our digital showcase, and people talk one-on-one, business leaders to technologists. What questions do you want them to ask you?
Well, so the questions typically that we get is, does it work? which is a funny question, because I can tell you right now, there is not a lot of people in the world that it can do what we can do, and that is navigate in an environment like a warehouse in a safe, effective, and accurate way, move through space and understand where all the inventory that it's looking at knows where it is. People don't necessarily believe that it can be as efficient that it is. And really, the questions are, will it work for me? Will it work for me in this kind of environment where I've got, 100, 200,000 square feet? And the answer is yes. And that is what's interesting about this type of technology. It's 90% of all warehouses could utilize this type of technology. Now, would it be typically deployed in a warehouse our size? No. I mean, this is an engineering warehouse. But anything above 100,000, 200,000 square feet, it's very appropriate for this type of capability. But typically, our focus has been more north of 500,000 to over 1 million, 1.5 million square feet, or if not 2 million square feet. That's it's been more between, the sweet spot is typically around 1 to 1.5, and that is, very interesting, complex, very high, and long aisles, a lot of density. As I say, I was in a warehouse last week, 1.6 million square feet, 220,000 bin locations. And I can tell you, I visited another one, 1.5 million square feet, 200,000 bin locations, 1,000 people, takes 3 months, to check the inventory. And we can do this in 140 hours with one robot, which is typically not what you would do, but if you had a couple of these robots, it just redefines how you do that today. And you have the opportunity to eyeball every single location in that facility.
Well, Matt, we look forward to seeing you at the summit.
It helps. Yes, absolutely. I'm looking forward to it myself as well. Thank you for taking the time today.
All right. Bye now.
All right. Thank you.